In this segment, we're going to take a look at excavation. And we're at the site where the old Michael Golden Laboratories were located, and we can see the result of demolition and a major excavation taking place. So when we're talking about excavations, we usually talk about trench excavation or pit excavation. What we're looking at today is a major excavation, that pit excavation, where we have dug out for the basement of a new structure that's going to go in place of Michael Golden Laboratories.
And what's that new structure? This is our new building.
Yes.
This is called the Gateway Complex. It'll be an L-shaped building that wraps back around, and construction management will be moving lock, stock, and barrel into the new structure. Great new construction lab, about 3 to 4 times of the size of the lab we have right now.
So Mark, what are you seeing out here that is a little different than what you see in your residential construction when you have a major excavation and we're digging all the dirt out for a basement?
Right, so typically in residential, we don't need to go that deep in the ground. Even with a 9-foot concrete wall, kind of a standard basement height, we may only be going in the ground 6 or 7 feet because we need that top of wall to stick out above the ground level, and then we need to do some drainage sloping away. So while we still have to worry about cave-ins and things like that, we are not 20 or 30 feet deep in the ground. Here we see, very deep depth, major excavation, and I see these big steel piles and lots of lumber, which we wouldn't see in residential. So what are we looking at, Scott?
So what we're looking at is what we use in commercial construction to maintain bank integrity. And what I mean by bank integrity is not only are we keeping the soil and the road in place, but what's underneath it. We have this entire infrastructure that goes underground here at Purdue University. That's all of our electric, all of our mechanicals.
Yeah.
And that's 400-pound steam right up to
chilled
lines.
Water,
Exactly.
Steam lines. Yeah.
So when we're building in and around other buildings, we have to go to great lengths not to disturb what's already in place, what's already buried, what's there, what's operating. We're delivering all the utilities to Purdue University through these branch systems. So we have to protect them. So we go through around the perimeter of the excavation, and they have taken these huge I-beams. It's just what we call like an H-pile, because an I-beam is in the shape of an I or an H if you flip it around 90 degrees. And what this does is they drive those piles down, and that gives us a rigid wall, the basis of a rigid wall. And then we come back with the native timbers. We've got, I don't know if they're 2x, but we're going to get...
We can see them stacked up over there, right?
Yeah.
Is that more cribbing, Scott?
Yep, that's more
Looks
cribbing.
like it's 3 or 4 inches thick, approximately, and 8 to 10 feet long.
So you see that we run the cribbing, the wood planking, we run those down the channels in our I-beams. And as you can see, we've welded clips on, and we're clipping the lagging to the I-beam. And what this does is it creates a retaining wall around your excavation. And we have 2 ways we could protect things, right? We can draw the bank, we can step it back, we can have an angle of repose for the soil.
So we dig our pit bigger than we need.
Right, and we slope the banking.
Okay.
But that's not feasible here. I mean, if you're going 15 feet down and you've got a 45-degree angle of repose, whatever you're down, you've got to travel out away from the excavation.
Right up against the back of Canoy Hall.
So we can see here that we have, up against the building, we have some sloping.
Sure.
And that soil's laying such that we're not going to have a cave-in come rolling down. If that was a sheer bank, we always run the risk of that soil losing its integrity and caving in. So that's why we travel and we spend a lot of money to protect the excavation and everything around it.
Sure. So is this our only way, or is there another technique that we might see in commercial construction?
Well, this is pretty much what I've used. Sheet piling is another, where we have these interlocking piles. So it pretty much looks like if you got a pole barn, the siding.
Oh, right, the metal sheets.
Yep, the metal sheets. So we get these large sheets that are driven into the ground. And it acts as the same retaining wall, and those sheets lock together, right?
And you see that a lot in seawall construction
Yes.
and wharf construction, so we can drive those sheets on to also help prevent cave-in.
Yeah, absolutely. So when they lock together, you know, we could put cofferdams in where we can pump water out and put caissons in the ground to support bridge structures, things like that. We've really, you know, the design kind of holds to this, but like anything else in construction, there's just multiple ways that you can accomplish the same thing.
Absolutely. Now around our piles here, it looks like it's like the dirt has been consolidated, almost like it's a concrete. So when they drove those piles in, did they add a slurry around them or something? Why do we see that big mass around the piles?
It all depends on what your soil is.
Okay.
You know, if we have good, I mean, look, we had a huge structure standing here that had a large basement and sub-basement in it. So that excavation was very deep. So you have to understand, when you come in and you build on an existing structure, all of that fill that was put in during the original building's construction is still there.
Which is not suitable to build on.
Yeah, it's not as good as virgin soil, right?
Sure.
When we have undisturbed soil, we get very cohesive qualities.
Right.
Right?
High compaction rates.
In granular fill, we don't get that cohesion that we get with normal loamy, sandy soils. When we add the rock and the fill to it, then we get something that we have to help the integrity of the soil, keep that retaining wall.
Absolutely.
Because we are relying on that substrate to keep our wall up and vertical.
Right.
And sometimes what we see, you can see that we have these big metal plates down at the bottom of the lagging at each eye piling. These are tiebacks, and we'll actually take an auger and we'll bore a hole back through the lagging, back through that, down into the ground at an angle.
Okay.
And then we slip rebar down there or a threaded rod down into that, and we pump high pressure grout into it, and it acts as a friction, right? So if we have
like an earth anchor.
Right, it's an earth, that's a great way to put it. All it is an earth anchor. You can think if we nail two boards together, we're using a mechanical fastener.
Right.
That's all we're doing here in this situation, but we're adding support to that vertical nature of the wall.
Keep the H-pile from
right.
tipping
So we're just,
in or
it's
kicking
just
that.
a bracing,
Yeah.
right, to keep it up and in place.
Looks like the nuts and washers on those anchors are this
They're
big.
huge.
I mean, the washers are like this, so there's
Right.
a tremendous amount of pressure on that setup.
We got a road that's maybe 10, 12 feet off of the cribbing. If you think about it, what if we roll a semi up on that that's
Right.
full of material?
Right.
And maybe we have something that's 150,000. Think about the pressure that's being exerted on that wall as that piece of equipment or that truck is sitting up on top.
We bring in a track or crawler type crane and park it next to the excavation to lift steel or concrete in. There's a lot of force right there on the bank.
Absolutely.
Yeah.
So that's why we see this it's almost like piling on steroids.
Yeah, absolutely. So we can think about this project. This was over a year in the making. They're still finalizing design, but this is fast-tracked, so they've started the demolition and the excavation as they're completing the design work on the other floors. But think about the logistics and the pre-planning that has to happen. Behind our excavation, this was a sidewalks and pedestrian walkway. But we lost a back entry and delivery method to the existing buildings. So this was all dug up. Some of our infrastructure was relocated, and they put in a temporary construction drive to serve as a way to deliver materials, product, people, whatever needs to come to the site to our site. So tight constraints, lots of infrastructure in the ground, and then a third thing, not the final thing, but a third thing we have to worry about when we have construction in an environment like this. Purdue has a tremendous amount of experiments going on, research going on at all times. So noise, dust, vibration from construction could disturb research going on in any of these buildings. And Purdue does a lot of vital research, whether it's going into space, cancer research, you name it, it's happening here on campus. We have to take that in consideration as constructors. Are we causing problems for any of the occupants of the area? Safety, here in a few weeks, we'll have our student body back on campus, all of our staff and our faculty, and we have all those safety concerns with pedestrians walking by our job site. That's why we see the construction fencing, we see signage, caution tape, you name it. We have to protect the inhabitants of the Purdue city during construction.
And I'm glad you brought up we'll talk about that for a minute, this fencing. Whenever we open the ground up and we have a hole, we have to protect that hole. We have to put signage up, fencing up. We have to draw attention to the excavation to keep people out of it. And Mark brings up a very good point. When you're working in and around on a campus or other structures, you're very aware of your foot traffic. Because we are responsible for everybody that comes in and around our projects. We are responsible for their well-being.
And multi layers of safety. We have this really for our occupants of the Purdue campus. Down in the excavation, you can see a double layer of wire rope with flags on it as another indicator, and that's more of a safety item for the workers on site that are working in and around the excavation for not necessarily fall protection, but as a way to highlight that there's a hazard right in front of them.
Well, we flagged you can see how the cabling is flagged. We've dropped colored ribbon off of it. That's the visual recognition, but that is actually a mid and a top rail on a system that is providing fall protection for anybody walking up around the top of the excavation. And that's crucial.
So we have this major excavation. Where'd all the soil go?
That's a good question, Mark. We have to take it off site.
Right.
Like Purdue University, they've got a lot of barren ground out South Campus. Usually we're able to go and work it with them. They'll accept all of the spoils. If that's not, our dirt worker's going to be responsible in their bid. The material that needs to leave site, leave site.
Right. And then at the end of construction, we'll obviously have to bring soils back to do any finish grade, landscape beds, things like that, and all of that has to be accounted for.
That's a good point, because say I've got 6 inches of topsoil on my site. Sometimes I'm required by contract to pull that up and store that on site to reuse.
Wow.
So we're trying to keep the good soil, and when we get down into the clay and that might get trucked off and dumped somewhere.
And this will all be back in those specifications
Absolutely.
on what we're required to do.
Unlike residential construction, where in commercial you don't have the latitude to make decisions.
Sure.
We can make decisions on methodology, right? The architects can't tell us how we're going to build it.
Right, right.
They just tell us how it's going to look, what all the parameters for that is, and then we go build it.